In this lecture, we're going to talk about GPU hardware and how that affects the programming model. So let's summarize what we've learned so far about the GPU programming model and start adding to it. In our last lecture, we learned about the programmer's view of the GPU, and I'm going to summarize that and then start adding some more details to it. So your job as the programmer is to divide up your program into smaller computations called kernels. So a kernel, in our case, is a C or C++ function. And the key idea of a kernel is that it's going to be performed by many threads. So a thread is a path of execution, a thread of execution through the program code. And I've drawn them as wiggly lines here because they're not necessarily all going to take the same path through that code. There might be branches like if statements or switch statements. There might be loops, for loops, do loops. So you don't know in advance what path you're going to take. This is not straight line code. And in fact, different threads might take different paths. So there might be a thread which takes a completely different path. So the key thing about threads is that they come in thread blocks. A thread block is a group of threads that cooperate to solve a subproblem. A GPU program launches many threads to run one kernel, like foo, and then they all run to completion and exit. And the program launches many threads to run the next kernel, like bar. Another thing to notice about the way I drew this is that you notice I have a different number of thread blocks with a different number of threads. That's actually something you can pick for each kernel. And we'll talk later about how you would, why you would choose different numbers of threads, different number of thread blocks, how you would organize these. So that's the programmer's view of the GPU.